Hello, in the last lecture I have discussed how to insert a key in a B tree. Now in this lecture I am going to discuss how to delete a key from a B tree. Now deleting a key from a B tree has several cases. Now we will be discussing these cases one by one with suitable examples. Let us first consider case 1. Now we have taken a B tree of minimum order T as 3. That means any node should have minimum of 2 keys and maximum of 5 keys other than root, and root should have minimum of 1 key and maximum of 5 keys. So now if we are asked to delete B, now case 1 is that if the node X containing B is a leaf node and it is having greater than is equal to T keys, then just delete the key without disturbing anything else. It's quite straightforward. Now we have located B here in this node. First of all, you need to search the key, and if the node containing the target key is a leaf node, yes, it is a leaf node, as we can see that this is a leaf node and this contains 3 keys which is equals to T, so we can just delete this, just remove this, and that's all. So after deleting B, the tree will be something like this, TG. So this is the first case. Now we will be considering the second one. Now let us consider case 2. Now if the node X containing the target is a leaf, but it is containing minimum number of keys. That means if T is 3, the target node that contains the target has only 2 keys, then there are 2 subcases. Case 1 states that if now our objective in this case is to delete L in this example. L, we first need to look at L. L is here in this node, so this is the node X. This node is the node X that contains the target. Now we need to delete, in order to delete L, we need to find out, since this is containing only 2 keys, that is the minimum key that a node should have for T is equal to 3. So we need to find any sibling of this particular node which is having greater than is equal to 3 keys, that is greater than is equal to T keys, and we have got 1 here. This sibling of X has 3 keys. So the idea here is that just find out the extreme key, appropriate extreme key. In this case it should be the left one. Had it been on the left side of the target node X, then it should be the rightmost key. So just find out the appropriate extreme key. Here it is O. Now move these here into the parent, and the appropriate extreme of the parent should be moved here into the target X. Now then you can delete L. So the next step should be something like this. J, the key O should go here to the parent, and then it should be GH on the left of this, and then we have K, L, M. M is moved from the parent to this target node X, and then we have here P and R. Now what we should do, we can now delete L. Since this particular node now contains 3 keys, so we can delete 1. Now L can be deleted. So after deleting L, we have this B tree, JO. On the left hand side, it is having the extreme left subtree contains G and H. Here we have K and M, and on the right hand side it's P and R. So that's case A under case 2. That's the subcase A of case 2. Now we are going to discuss the other subcase under this case 2. Now this is the second subcase under case 2. Now here, if the target node contains T minus 1 keys and none of the siblings of the target node has greater than is equal to T keys, that means here the objective is to delete S, and we can locate S in this node. So this is the node X in which we have the target. Now if we look to its siblings, that means this one and this one, all of these siblings of this target node X has minimum number of keys. Here it is 2 keys, here also it is 2 keys. So the idea is that in this case, the idea is that just merge this target node X with either of its sibling, that means either with this one or with this one, and then merge by considering the parent key, that means this one, as the median. That means after merging it should be something like this. After merging we have Q in the parent. Say we are merging this node X with this node that contains W and X. So after merging it will be OP here, and T will come to the child RSTWX. Now we can delete the target node S from this. Now this contains more than greater than or equal to T keys. Now this node X that contains the target has more than or greater than or equal to 3 keys. So we can delete S right now from here. So now we can just delete S from the target node X. That's all. So there are 2 cases. In the earlier cases, what we did, in the earlier case, the target node that contains the target key has T minus 1 keys, and it had a sibling which contains greater than or equal to T keys. Here T is 3, so this is the minimum number. The minimum number of keys in a node is, other than root, is 2. So the target node contains only 2 keys. And now if we delete 1 key, so it will violate the condition for B tree. The minimum number of keys will be less than the number of keys here will be less than the minimum number of keys. That's a violation. So we cannot delete L in this case. So what we did earlier, we found a sibling of the target node X which contains greater than or equal to T keys. That means here it is 3 keys. This sub sibling contains 3 keys. So we actually moved the extreme key of the sibling to the parent and the appropriate extreme of the parent to the target node X. And after that we got this, and where after doing that we have deleted successfully L. That was the target. Now in the second case, as we can recall, here neither of the siblings of the target node, here is the S is the target key, so this is the target node, and neither of the sibling has greater than or equal to T keys. All the siblings of this target node has minimum number of keys. So here we just need to merge the target node with either of these siblings. I have merged it with this one. So these two are merged, and what we got by taking this T as median, and we moved T to the leaf node, the target node, and we got T here, and then we have deleted successfully the target node, target key S. So this is case 2. Now if the target node that contains the target key is an internal node, that we'll be discussing with case 3. That's the thing that we'll be discussing in our next slide. Now if the target key is in an internal node, then we have 3 subcases. Now case 1 states that if the target key's left child's root has at least T keys, then its largest value can be moved to the parent to replace the key. Now if in this case, in this example, we have an objective to delete U, that's the target key, we locate U in an internal node here. Now we observe that the root of the left subtree, that is this node, has T keys, that means 3 keys. So we can move this extreme right key, that's the largest one, to replace the target key here. So what we do here, after replacing U by T, the tree becomes something like this. OP comes. Now consider the subcase B under case 3, that is this one. Now in the earlier case, that means in the subcase A, we would require to delete this node, this key U, where it has a left subtree subtree root with t keys. Now here in the subcase B under case 3 we need to delete key I that is located here, that can be located here, which has a right subtree root with t keys. In the earlier case it was a left subtree root, so we moved the rightmost key, that's the maximum one, to the parent to replace the target key, and here the target node is I, we need to delete this one, and we have a right subtree root with t keys. So what we need to do is to move the minimum, the lowest key, that is J here, into the parent to replace I. So J should be moved to replace I into the parent. So after replacing the key should look like something like this. The root node should contain J and M, and then so on. So we have deleted successfully I in this case. Now we are going to look to subcase C under case 3. Now here we are left with the last case of this session. Now if the target is U, we can locate U here in an internal node, and we observe that neither of the subtree roots of U has at least t keys. T is 3, so it contains t minus 1 key, and it also contains t minus 1 keys. In the earlier cases what we had, we can look that here you had a subtree root which had t keys. In this case also I had a right subtree root which had 3 keys, but now we have to delete U, where the left subtree of this U has a root node that contains only 2 keys, that is less than t, and again the right subtree also contains 2 keys, that is less than t. In such cases what we need to do is just to merge these two nodes. The idea is just to merge these two nodes and then replace, and then just delete U. So after merging them, what you get, the tree should look like something like this. R U X, what do we do? Just need to merge these two subtree roots of U, so they are going to be merged. R X, after deleting U, the P tree should look like this. So we have successfully deleted the key U from this tree, and we get this particular tree, B tree. So I have discussed all the cases those are possible while deleting a key from a B tree. I hope that you have enjoyed this.